Hello, today we're going to look at applications of the dot and cross product. Okay, let's see what questions were asked. So if vector A is given by 3, 1, 2, and vector B is 2, 1, 4, are the sides of a parallelogram. So these two vectors are the sides of a parallelogram. Find the area of the parallelogram. Okay, so let's draw this out. So we're given a vector A and a vector B. And obviously they form the sides of a parallelogram. We're asked to find the area of this parallelogram. Well, so we have this application of the cross product. So if you take the magnitude of the cross product, this actually equals the area of the parallelogram described by those two vectors that we're taking the cross product of. So let's use this application. Let's pick a color. All right. So we want to find the cross product of A cross B. And how do we do that? We make our box of numbers. So IJK in the top row. The second row we have A, so 3, 1, 2. Third row we have B, vector B, 2, 1, 4. And then let's take our cross product. So I, coefficient of I is the first box, so 4 minus 2 minus J, coefficient of J is 3 times 4 is 12, minus 2 times 2 is 4, plus K, coefficient of K is our second box, so 3 minus 2, and we have 2I minus 8J plus K. Now that's a vector, so we want the magnitude of this vector, magnitude of A cross B. It might be a little easier to find the magnitude if we write our vector in coordinate forms. Our coordinates are 2, -8, and 1. So now to find the magnitude of this vector, we take the sum of the squares and then the square root. So we have 2 squared. Scroll up, give ourselves some more space. Plus -8 squared plus 1 squared. And what do we end up with? We end up with 4 plus 64 plus 1. This is the square root of 69. So the area of our parallelogram described by these two vectors A and B is the square root of 69. So we'll just scroll over and write a little concluding statement. So therefore, area of parallelogram equals square root of 69 units squared. All right, we have another diagram down here. All right. Okay, let's have a look at our second question. So a 55-gram boulder rolls down a slope at an angle of 30 degrees to the horizontal. Calculate the amount of work done. So I do have a diagram here. So let's see what this diagram is about. Oops. Okay. All right, so let's take some of this away so we don't give the answer away. All right, so we have this nice diagram. It looks like we have a boulder. Looks like we have our boulder at the top. That's our 55-gram boulder. And we have our incline that it's rolling down and the angle of 30 degrees that it makes with the horizontal. So we have some sort of right angle triangle here. So the sum of the angles in the triangle is 180. So we know this third angle is 60 degrees. We have the mass of our boulder. So we know the force due to gravity applied to this boulder, so the vertical force downward, is given by mass times acceleration due to gravity, which is in our case, 55 times 9.8. That will give us newtons. So we can actually calculate that. 55 times 9.8. We end up with 539 newtons. And that's vertically downwards. So perhaps the work done is going to be the hypotenuse of this triangle. So the vector of force going downwards, that's going to be our work. So let's calculate that. I think we can calculate that using triangles and trigonometry. Okay, so we know the length or the magnitude of this side. It's 539. We know the angles in a right angle triangle, so we can definitely find the magnitude of our work. Right. So let's have a look. So the tangent, why don't we write it this way? Or better yet, how about the sine of 30 degrees equals opposite over hypotenuse. Opposite is a magnitude of our force over due to gravity over magnitude of the work. We're looking for work, so we're going to solve for W. So magnitude of work equals, let's scroll up, give ourselves some space. Magnitude of force due to gravity over sine 30 degrees. Let's plug in all our values. Magnitude of the force due to gravity is 539 newtons. Sine of 30 is 1/2. So this actually equals 1,078 newtons. That's the magnitude of our force. The actual direction of our force, we can say that it is, what's one way of describing it? 30 degrees below the horizontal. So the work, so I guess the same. So our work is 1,078 newtons down this incline, which is 30 degrees incline from the horizontal. So we use the same wording that was given in the problem. So the work, why don't we put here, work done equals 1,078 newtons down a slope at an angle of 30 degrees to horizontal. Good. So in this case, we didn't use the dot product or the cross product. We ended up using just trigonometry. Well, that's good too. All right, so finally, third question. So we have vertices of a triangle, A, B, and C. We're asked to construct vectors A, B, and BC, and then we're asked to find the area of the triangle. So this question is very similar to the first, except instead of finding the area of a parallelogram, we're finding the area of a triangle. The area of a triangle is half the area of a parallelogram. So we just take our result of finding the area of a parallelogram and divide it by 2. So why don't we do that? Let's pick a different color and let's start. So A, let's find our two vectors, AB and BC. So B minus A is 0, 1, 2, minus -1, -1, 2, -3. So our vector BA is 1. 1 minus 2 is -1. 2 minus -3 is actually 5. It's our first vector, AB. Our second vector, BC, C minus B is, the C is 1, -2, 1, minus B, 0, 1, 2. We have 1 minus 0, 1. -2 minus 1 is -3. 1 minus 2 is negative 1. So vector BC. So we have our two vectors, great. Now part B, find the area of the triangle. So we need to find the cross product of these two vectors to start with. And then finally its magnitude, we take that divided by 2, but let's start with the cross product. All right, cross product of AB and BC. So we're going to make our box of numbers, IJK in the first row, AB in the second row, so 1, negative 1, 5, BC in the third row, so 1, negative 3, negative 1. All right, and let's see what we get. I times coefficient of I is negative 1 times negative 1 is 1 minus negative 3 times 5 is negative 15. Okay. Minus j times coefficient of j is 1 times negative 1 minus 1 times 5, good, plus k. Coefficient of k is our second box, so 1 times negative 3, negative 3, minus 1 times negative 1, so we get plus 1. All right, let's write this out. So we have 16i. It looks like we have 6j minus 2k. Let's write this in coordinate form. 16, 6, negative 2. All right, so now to find the area of the parallelogram, we need to find the magnitude of this cross product of this vector. So that's the square root of 16 squared plus 6 squared plus negative 2 squared. Okay, I think we need our calculator for 16 squared. 16 squared plus, oh, it's not right there, it's 6 squared plus 6 squared plus negative 2 squared, so we got square root of 296, and that's approximately 17.20. However, we're looking for the area of the triangle, so therefore area of triangle, I think it's ABC. ABC equals 1/2 of the square root of 296. Good. That brings us to the end of our session today. If you have any questions, please send us a note at info@raisemymarks.com or give us a call day or evening, and we'll be happy to answer your questions. Thank you for watching, and we look forward to seeing you soon.